Pretty strong, right? That's pretty strong. I can't imagine it
It's
falling
cool.
down ever. You really want it?
Yeah, go ahead. You have to build it back though. It's not gonna break though.
So I see you have 4 tires here.
Yep, and 2 engines.
So, but all 4 tires aren't touching the ground. So,
Or is that just because
oh, okay, I see.
Yes.
All right. So, is there anything you want to tell us about your robot before you show us?
Can I see
Yes. We built the 4 wheels for the bridge to steady it because if we have the 4 wheels, then the weight can just stay like that.
And we had a problem. There was too much weight in the back, so it was flipping over. So I made a wheelie bar, and they also made a stopping bar on it because it kept falling over them.
So when it went off these stairs, it always tipped that way, and it always flipped. So I built the front piece of it right here.
And here's our stopping bar.
It's a wheel.
Or
That's
wheelie
the
bar.
wheelie bar. That's
And so it's intended to be flexible a little bit, or kind of
Yes.
rotate a little bit.
And let's try it.
So your guys' robot can pop a wheelie?
No.
you had it at 100%, and it always
Yeah.
jumps. It
It
goes.
goes like, it used to go like,
It used to like jump.
okay, let's try it.
We also made it came with the 6-inch little
Be hilarious if
uh,
it was a
wheel brackets or whatever you want to call them, and he shortened them because the wheel would always slide on like in and out like this because they were too long.
I shortened them and put things inside of them so they're still. And sometimes the tires can wobble a little bit. And
Make sure all
okay.
the tires are on
Do
there.
the tires wobbling cause problems?
Sometimes.
Well,
it can take it off. Now that we moved, it was actually on this.
When we were doing this, it went off course and went like that, and because one of the cords got caught right here and went like that.
We shortened the cord. And in one of our practices, it went here and it did this thing and went about
It
there.
wasn't actually
Then it
hurting
came and
anything.
it just
Crashed from that, but we took out that, so we have it do that, and then we're gonna have it do the chair, and
That's
then we're
the
gonna have
bad
it
thing about
bounce on the
having 4
bridge
wheels.
for last.
But we doubt we can get the chair.
Excellent.
Well, you
working on
guys,
it, though.
you guys show us something. Which program's your favorite program?
4-wheel. Actually, it's weight machine.
Wait,
weight machine.
At first it was called 4 wheels, but now we changed it to weight machine.
Okay.
That's the weight machine.
it'd be like his zone and all
And we thought at our home board that it used to go like that to jump sometimes, but it was just because we had a bad mat and it was all messed up. We had to put tables together. It jumps.
Oh, I did
Stuck
that.
right there.
Can I
Did
try that
that
again?
earlier.
You sure can try it
Go
again.
for it.
All right, thank you.
Did it even lift it up at all?
No.
Not even one notch.
It got caught on this.
Alright,
Back
yeah.
up just to like. Yeah. Said we can't use it right now.
It'll jump each way every time. So it's almost like
Make this a little bit lower then.
No, that's not the flag. It's jumping weights. If it jumps, the wheelie bar's not going to go at all.
Unless it makes a big wheelie. Steven, don't lean on the table.
It actually was making big old wheelies before. We made that turn.
Try another thing.
So what?
Drive the bridge.
So I noticed that you guys are putting your robot in the middle of the home base. So what is your? How are you guys actually determining where to put that? What's your method for doing that?
We just
Cold.
Okay. So what's your technique? How do you know where to place it?
We use these measurements right here,
Okay.
and I line it up.
In one of our practices, we built like the wheels and wheel places. We built them.
But it'll jump, and it's hard to tell which way it'll go. Like,
Yeah, turn the power down some more.
let it go, let it go.
Gotcha.
we gotta make that turn.
So
a little
let's
wider.
talk about that for just a second. You said we got to turn the power down just a little bit.
We have other programs.
We have our power is at 100, so we
Here's
should
a
probably
chair.
put it at like 75.
Sure. So that's a very good observation. So you say here that it's jumping. So by reducing the power, would that help fix that?
Possibly, yeah. It did on the bridge.
We got it this time, but not that.
Oh, we got it that time.
that while I fix it.
Oh, that's what that second thing that was pushing it back.
Should have used the block for that.
yeah.
Yeah, there you go. We've never actually gotten that one to work before.
That was the first time.
Actually, I think we should just keep it.
We didn't know what the heck that one was, so.
If it doesn't work, Cole, maybe we should just keep it in base and earn the points that we can.
It might
Well,
have.
we can't lose points, really.
It might help if you.
Now we can.
And that's a little too long.
Just leave it in base.
So do you guys happen to have a copy or something that I can see the code that you guys use for programming?
No. I can grab the computer and show you.
Yeah, absolutely. If you want to have somebody grab the computer, we can certainly take a look on that.
And we'll show you the bridge while he goes and gets that.
Should we find up right? Should you have this up?
Actually,
Don't get on there.
because that never seems to go.
Never mind. It always works best when you
That's
kind of.
Oh, that's good.
Another
Stop
one
it,
goes.
man. Stop it. I was about to hit that. Yeah, it's there.
So for our weight machine, that was our program. And we went for
That's okay,
8.5. We haven't showed you the bridge, but that's our chair. That was the one that performed the chair right.
You're not using any sensors, right? So you're just kind of basing it off of how far it goes. How did you decide in your program how far to make it go?
Well, we started little, and then if it was too short, we
built it in
thought
segments.
about
Okay.
a little bit more.
Well, we first
did this.
before we even started the mat. We had this tape, and we were supposed to make the robot go on the tape, right?
Ah, there's the good run, guys. There's the good run.
The wheels.
Yeah, I was gonna say that wheels.
The wheels are kind of
This
curving.
wheel is
Madness.
Well, we can't help it.
So have you found that the four-wheel design is working really
Yes,
well?
it works.
Yes, it does.
Or do you
The
think-
three wheel will get stuck in those.
Yeah, and three
Try this, and then it goes.
like it had the weird
Then
back
tip
wheel.
over
If you
and
started
smash
that
it.
weird, it would mess up with the.
Is that the bridge?
It's like Jack and Jill just having an even more stay. After they've already been in the hospital once.
At least it makes it off the bridge without dying.
So I have a question. So let's talk about this bridge. What can we maybe do to make it easier to jump this gap right here? Because this is a pretty big gap.
Bigger wheels.
Okay. So
But
what do bigger wheels do?
They give it more room to.
they gave it more speed.
Yeah.
It's a little bigger, and then we got more.
The way this design was built, we couldn't make the wheels any bigger or else it would destroy the whole thing.
Hey, did we make a bowling one yet?
No,
No.
and we're not going to.
Not yet.
Yep.
Let it go.
No.
Let it go.
Gabe, we should.
So how reliable is this? Does it have a lot of problems with like making sure it's getting the missions done correctly? Do you guys have a
Doesn't have
Not really.
Sometimes.
If we have the power too high, that's mainly it, because it jumps
Hey,
in the beginning,
Gabe,
and
do
the
you-
start is everything.
Gabe, do you
We
still
had
have
a lot more problems
Right
with
there.
the three.
I don't have the
What
cord.
you? Oh.
What was the
Sorry.
first mission you decided to try and
The
program?
Weight machine.
The weight machine. Why'd you pick that one to do first?
Because we thought it'd be the easy.
I was
And
working
we
on
found a
trying to get
flaw
the
in
weight
that, and I had
machine,
to
and
go
I
back
finally
and
got
strip that thing down and fix it. Because whenever we used to pull the lever up, it would go a lot shorter distance. The more you, and the thing wasn't all the way connected. And here, this blue part that's in here somewhere, it wasn't. It was a black part, so it didn't get all the way across there, and it used to make the wheel go crooked all the way up and catch on that. So
Okay.
that really screwed up.
You tried doing that
We were so
dog,
confused about that. And I looked at
I didn't know we could grab it. After we push that, are we allowed to grab it and pull it into base?
the
Oh
robot.
yeah, right now you guys are fine to just show us how it works and how to
How long do you think it
Just
took
bring the
you
robot came.
to figure out how to do the weightlifting? So this was been your first tactic.
Probably a
minutes
day.
or tries?
And tries. And how many tries do you think it took
Oh,
to
gosh.
measure
About
out?
20.
Maybe more.
20, maybe more.
It's not very easy.
We started out just down here trying to get it to lift up. Then we got it from base down here.
Mr. Meek told us to go from base all the way to here and do all
And how did you decide how to make it go that far? Did you
We just
measure how far a
trial
cycle
and error.
went, or just completely
Trial and error.
Okay.
Trail
At first it was 9 and that was too short, then we tried 10 and that was too
So
short.
Then we
did
did
you,
8.5.
were you able to use that knowledge then to do other tasks? Did
Yeah.
you know how far it should go
The
based on how many
Yeah,
revolutions?
that's how we did the bridge.
Bridge we think was the hardest, but it's the
So,
Oh, just because it.
is there another method that you possibly could have used?
Didn't even touch it.
Is there another method you could have possibly used to
Yeah, you might want to stop
measure
that.
the distance?
Would you probably?
Is there something that you guys could have done differently to maybe measure the distance?
Done one rotation.
Can I check something real quick on
Yeah,
here?
and then just like measured out, like say this is one rotation, one rotation.
Awesome. Okay, yeah.
We could have done how many seconds we wanted We could have done how many seconds we wanted to drive forward.
It looks like its turns too short.
So it seems to be consistently turning too short. Why do you think that is?
Because we haven't programmed on that for a while. We were told not to
We had-
mess on something.
Yeah, because we had to
Since
leave.
it, whenever it comes on the bridge, it's always over here, and it's always over here, we should start more that way and back.
Do you think it's in your program or on how the tires are functioning?
It could be.
Tires
I
are
think
it could
it's
be
just our
anything.
positioning.
So, if you guys had the chance to change something about your robot, what would you change?
I'd add some